Welcome back to the Aussie Shed, ladies and gentlemen. As you can see here, the refangled control box is all prepped and ready for paint. She's a pretty janky kind of a piece of crap though. As you can see here, the shape of this thing. She's all kind of folded in on the sides. About as straight as a dog's hind leg. When it goes onto the base section that it mounts onto, because it's so sort of caved in on the sides, it doesn't line up and seal properly, so I think I'm going to have to make up some kind of a rubber seal out of some silicone or something so that this thing seals up a bit better. Being the fact that it's all jam-packed with gear now, I don't want chips and all sorts of crap getting in there. So yeah, that'll be a bit of a project. After it's painted, I'll sort of work out what I'm going to do with that. It's had all sorts of filing and bolt holes kind of elongated so it all actually fits up on the lathe a bit better. Very, very poor fit and finish on this piece, by the way. I don't know whether mine's particularly worse than anyone else's, but believe me, it is an absolute piece of crap. So, moving on. I've drilled some speed holes in the bottom here, just to get a bit of ventilation up through it. Motor control has quite a reasonable heat sink on it. From my experience, they don't get very hot anyway, but a little ventilation would be great. To be able to get ventilation in without ingesting chips and all sorts of crap, really the only opportunity as far as I can see is to you know, pepper the bottom full of holes. And yeah, we'll kind of see. We'll just monitor it. I may even put attach some way of monitoring the heat of the heatsink in there, but honestly, I really don't think it'll be necessary. If my motor controller craps itself from heat, I'll just spend 12 bucks on another one. It's no big deal either way. So, as you can see, it's just had a bit of a rub down as best as I can do and patch up a few holes and just kind of patch up the join between this new top piece. This the base section here, same deal. I've drilled and enlarged a few holes just for the extra cabling to run through. And other than that, that's about it really. So might start throwing a bit of paint on it. Might just blast a little bit of etch primer over the top of this aluminium, and then hit the whole lot with just a general purpose primer. Yeah, and then throw in a bit more of this silver hammer tone, but I might go to a different colour. I originally wanted to leave this white, but after I started working on it, chopping holes and stuff, it was apparent just the absolutely piss poor sort of condition of it. And, you know, when I did the top and everything, it's like, we'll see. I might put a darker grey on it. Maybe a darker hammer tone. Anyway, let's get a bit of primer on it. Etch primer's on the top, going for a bit of general purpose primer. Rightio then, let's throw a bit of real paint on it. initial miscoat. That'll do the job. So here it is in all its glory, ladies and gentlemen. I ended up using a darker grey hammer tone finish. Pretty good. You can't, there's no real visual join from where the new top was made. As you can see there, looking pretty sweet. Just looks like it was always that way now. Where I did these speed holes in the bottom, I chamfered all the edges of the holes, and I've put some quite fine mesh in the bottom there just to prevent anything kind of going up there. It's the very bottom of it anyway. It's quite sort of protected. I can't imagine stuff's going to get in there, but for just in case, bit of fine mesh. But yeah, she turned out pretty damn good. Quite happy with that. There's the back plate for it, same deal. Painted up. I ended up chopping these holes out even more than I did before. There were just holes there, and I've ended up just cutting them out with the Dremel and turning them into long slots, just so I can get connectors through, because I'm gonna, the way this kind of mounts and everything, it's a bit of a bugger. So I think I'm gonna have to have connectors coming off the cables that I'm gonna have to try and sneak through. Anyway, that's a problem for later. But yeah, this turned out alright. It goes together like so. A little bit crap. I'm still a little bit concerned about this the join between the two. But yeah, she turned out pretty good. Quite happy with that. So next thing to do is repopulate it with all the components. Fantastic. I've just screwed the box back together. There are 6 screws that hold the two pieces together. 1, 2, 3. They're in the top. Here, 1, 2, 3 in the bottom, and it's actually coming together reasonably well. You holding it up to the light, you can't see any light through the joins. So I think at this stage I'm not going to worry about trying to put a seal in there. It actually went together, like I say, better than I thought. I had done a bit of work filing all the edges up to try and make it fit together better, but it's actually turned out better than I thought it would. So at this stage, I think I will not use any sealant on it, but just monitor it. I'll obviously be probably pulling this apart in the early stages of the lathe running anyway to make further changes to stuff. So I'll just keep an eye on it. If it does seem to be getting any kind of any swarf of any kind in there, I'll do something with it. Everything else that goes in, all these switches and everything have seals on them. The tacho display doesn't have a seal, but it fits really nice and neatly and tight. There's no gaps on anything, so I think it should be okay at this stage. So one less thing to do. Fan-bloody-tastic. Alright, I might start putting a bit of gear back in this. In with the tack display. Look at that. See here, nice rubber seal on this switch. Just what we want in a situation like this. that's a good sound. And here we go for a big mass of stuff that I pre-wired up before that hopefully will just go straight back in. Yeah, it'll be right. So that's our controller in there. The bridge rectifier's just been screwed into the side. On the inside edge there, I've just used a piece of aluminium as a spacer between it to get over all these fins and everything that's on the edge there, just to keep it nice and compact. And you know, I'm trying to use every bit of space inside this box in the most efficient way possible, just because there ain't a lot of it. What a mess. So, let's try our switch in next. So this switch here, I'll just zoom in on him a bit. This is your original forward reverse switch from your mini lathe. This is a Kedu ZHA. Now this comes in quite a few different configurations with all these different layers. It can be used in a single layer, double layer, triple layer, and I think there's even a couple more, maybe a quadruple layer. I've downloaded a schematic from the manufacturer of this switch, which I'll put up in a second. So basically what we have with this switch is basically the two wires that come from the bridge rectifier, which the other side of the bridge rectifier is fed by the SCR. They go into terminals number 6 and terminal number 4. Now, which one you choose to use doesn't really matter. It will just change the forward and reverse on your switch. So if forward is reverse and reverse is forward, all you need to do is flip these two terminals over and you'll be good to go. So either of your output wires into terminal 6 and terminal 4, and then on the output side of your switch you've got terminal 5 and terminal 3. Now as you can see in this situation, I've just colour matched the sides with the wires, so I've got all the red on this side, which is terminal 6 and 5, 6 being input, 5 being the output, and on here with the black wires, 4 is the input and 3 is your output. Now that works absolutely perfectly. I've already had this rig together and running, and it works absolutely perfectly. So you've got forward and reverse and off on this switch. Works like a champion. It seems like a pretty decent quality switch as well, so a good component to reuse from your original layout. The switch also has a nice rubber seal, which I will reuse to get us a good seal on the new box. Yeah, I'll get this on and we'll screw this bugger in as well. So there she just goes on and clips into a couple of spots nicely. And then over we go, in through the hole. Beautiful. Snug as a bug in a rug. Very nice. Yeah, just to reattach this thing. Yes, this just did not want to come off originally, so so be careful with it when you're trying to get it off. There's sort of a, if I can just show you here. Come on, baby. There's sort of a clip around the center here. There's one on both sides. I'll just grab something to poke it with. There's a little clip here on both sides. You can see it just pushes in a bit. There's two of them. Now, I didn't know that was there, of course, because I've never pulled one of these apart. And that actually locks this cover on. And bugger me, it was trying to work out why the hell it wouldn't come off and not destroy it in the process of trying to get it off was not easy. So, if you are going to pull this switch out, remember, getting that cover off so you can get to these screws, you've got to be so careful. You've got to get up under the edge, very, very carefully, put a bit of pressure on it, and then push these plastic locking pins in on either side in order to be able to get the bugger of the thing off, like I say, without destroying it. Wasn't easy. I damaged one corner slightly. You can see there's a little bit of a crease mark in it on that corner, but I think it'll be okay. It's quite flat, but I guess we'll get it back on and see what it looks like. Not too bad. Sits on there pretty good. I think I'm happy with it. Yeah, it's not too bad. Be pissed at myself for damaging this corner, but it's not going to come off. It shouldn't lift. If it does, I'll just make something else up for it. I'll make something up out of a bit of aluminium and just engrave it or whatever, but I don't think I need to for the time being. I think that's fine. Fine. I'll just reconnect the tack. Now, where are we here? As you can imagine, it's getting hard to find space to get your fingers in and all this crap in here. Grr. Come on, baby. There we go. That's in. Very good. All right. This is the switch to switch between the two Hall effect sensors for the tacho display. It works really well. Like I say, I've had this up and running and it works as I planned it would, which is bloody fantastic when a plan comes together. You can't hope for much more than that, ladies and gentlemen. A win is a win is a win. These thin nuts are always a bitch, aren't they? Alright, we're good now, we're started. Beautiful. Very nice. Our potentiometer. Here she goes. Should be pretty good there, I think. Nothing's going to affect the wiring. Alrighty. Beautiful. We are getting there. What now? I want to throw the light in next. It's just a 12 volt light. There's a small step down transformer here that outputs 12 volts. I've just got this powering the light and also the tack display and the Hall effect sensors. Only a cheap thing on eBay. I'll put links to all this stuff in the description when I do it. But yeah, it's just a cheapie. I'm actually going to change this out later for something with a bit more grunt to run this stuff. This little bit of secret sauce down in the bottom that I haven't talked about yet, but we'll talk about that later. So yeah, for the time being, this is just a, like I say, little transformer to run the display and the light and, you know, Hall effect. I think I should have put this in before the potentiometer. I'm going to struggle with it. I just know it. Nice little light. Certainly looks the part. She's certainly looking the business now. Grr. Come on, baby. Oh, look at that. I've jagged getting it started. The old scriber start. All we got to do is just tighten the fucker down. It might be a job for the long nose pliers. Well, that went in easier than I thought it would. Alright, well that's everything in. Now we just got to connect it all back up. This is the schematic for the forward reverse switch on the mini lathe that I downloaded. I'll stick it on the screen there so you can either take a screenshot of it or whatever. It was pretty hard to bloody find this thing, let me tell you. Anyway, we've all got it now, so fantastic. Alright, this is tidy enough now that we can sort of see where we're at and I can run through it quickly with you. I'll just go over the rough layout of this. If you want to see how I wire these motor controllers, I'll put a link to my motor controller video up here. And this is all wired up exactly the same. The only difference in this is the forward and reverse switch, and what else we got? There's a fuse, I think, and I don't think I went over the magnetic switch, but it's very simple. Oh, and also switching between the two Hall effect sensors. So I'll start here. So this is the back side of the power plug where your AC power comes in. So you've got red, black and green. Red is active, black is neutral, green is earth. In my country, red is referred to active. In your country, it may be referred to as hot or live or any number of other things, but for the rest of the video, I'll refer to the AC positive as being active. Okay, so your active comes in from here and then snakes up around the back of the controller here just to get everything to sort of fit, and then runs up to your fuse. So one side of your active goes to your fuse or circuit breaker, and then the other side comes straight back out, so that's into the fuse and then out to the switch. So this is our output to the switch on this side, or sorry, our input to the switch on this side, and this is our output on the other side. These magnetic switches not only do the active, but they do the neutral side as well, so you're switching both active and neutral. So in the same situation, the black wire comes straight up from the AC input, doesn't go to the fuse because the fuse is only on the active side, and goes straight into the switch on the top side, and the bottom side of the switch here is your neutral output. Those two wires then come back down and into the controller. So this is your active in and neutral in these two positions. As I said, all this section of it is outlaid in the motor controller video. From this point, the wires diverge into the bridge rectifier. Once again, back to the other video, bridge rectifiers are wired in diagonally. So, you know, you got active in, sorry, you've got your outputs from here, one side to the other. Watch the video, it'll all be quite obvious. So the output from your bridge rectifier, which is your DC output, now runs to the forward and reverse switch. As I mentioned, you have two inputs and two outputs on the forward and reverse switch, which I went over earlier. Your input is you're in on number 4 and number 6. All the connections on this original mini lathe switch are numbered. So you're in on number 4 and number 6, sorry. And you're out on number 5 and number 3. The polarity of those doesn't really matter as long as you have the two inputs on the correct numbers and the two outputs on the correct numbers. They only affect which way the motor runs after this point, and you can just reverse it here or reverse it on the motor if in your final configuration it's running opposite to the way the switch is marked. Variable speed obviously runs from your potentiometer, which plugs straight back into the circuit board here. It's been removed off the front of the motor controller and just relocated into the board there. Your earth wire, as it comes up out of your AC in connection point, I've just drilled a hole in the side of the heatsink in this position, put a bolt through with a nut, and then I'm just using it as a stud. It earths the body of earths the heatsink of the motor controller, and then gives us a position that we can then use to continue our earths from anywhere. So earth in goes to that, and our earth out goes straight into this wire here, which is our output wire, which goes to the treadmill motor. And the other output wires come straight off that switch, which we mentioned earlier. The inputs come from the bridge rectifier, and the outputs go straight into here. So you've got your two outputs, active and neutral, or whatever they are, it doesn't really matter, go into either side of your output wires, and also this continues your earth. So you've got a direct connection from earth all the way from the switch into this wire. As we bring this wire back and through and onto the mini lathe, we'll then create other earth points in the connection box, which I'm going to make to earth out the body of the lathe and everything as well. Okay, so that's our power side of it. I'll just go up the top here and zoom in. Coming directly off the switched side of the switch on the front, off your main power switch, is another wire here. So this is your mains voltage out, which goes into a small step down transformer here that I just got on eBay, which is 220, 240 volt in and 12 volt output. Now I'm just going to use this to supply power for the tacho display and also power for the two Hall effect sensors. So as I say, straight off the switch into this on one side, and the other side, which is, they're a bit janky here. They have two red wires, of course, being Chinese, they don't really give a shit. What you need to do is just take this plastic cover off. It just clips off if you do use this particular thing, and it has it marked on the circuit board, which is your live or your line in or your active, and which is your neutral side. So just make sure you can see there's a black wire that goes into one. This also is your neutral straight off the back of this power switch here. So your active and your neutral that powers this step down transformer comes from the back of the power switch. So we get that wired up, and now we've got a 12 volt output on the output side of this. This powers, as I say, it powers the tacho display, and it also powers the two Hall effect sensors. On the negative output side, I'll zoom that back. My hands are looking a bit big and they're kind of blocking everything. Okay, this is your negative output side on the 12 volt. This is where you just join everything. Okay, so all of the blue wires from your Hall effect sensors join to the negative output from your 12 volt power supply, and also the, where are we? The number 2 wire from the back of the Chinese tacho display. Now all your negative connections join in that. So it's blue wires from the Hall effect sensors, 12 volt negative output, and also the number 2 wire from the tacho, which is the negative. Your number 1 wire on the tacho loom is your power in. So as you can see, it's connected straight into the positive side of your 12 volt output on your transformer. And also we have another wire which comes off here. Alright, so I'll just show you these. I'll go through all these wires. So this is your 12 volt output from your transformer. One's going to the power on light because I'm using a 12 volt power on light. So obviously power comes on, that gives us our light. This one is to the tack display, and this one here goes into the first section of this switch. Now that is our power wire that gives power to the Hall effect sensors. And you can see here that red wire goes to the center terminal on this side of the switch. It's a dual pole, dual throw switch, so it has 3 connectors down either side. So what happens when you flick the switch, it joins these two on one way and then these two on the other way. So your center can be used as either a common input or a common output. On this side of the switch we're using it as a common input. So what's happening is when we switch the switch, it gives power to either one of the Hall effect sensors, but not both at the same time. So whichever sensor we are looking to get a signal from is the one that we give power to. Now the 3 terminals on the opposite side of the switch, which you can't see but are exactly the same as this, they have the black wire from the Hall effect sensors running to them, and the center wire we are using as a common output. So on this side where we've got power in, we're using it as a common input, which is then distributing power to the Hall effect sensors, and on the other side we're using the center as a common output, which is going back into our tack display. Now it is wire number 5 on the tack display, which is the signal input. So what happens when this switch is flicked, it joins either one Hall effect and the output, or the other Hall effect and the output. And it's just wired so that it's the same Hall effect sensor as the power is being supplied to. So one Hall effect sensor gets power, and then its signal gets transported out to the gauge. Flick it the other way, the other Hall effect sensor gets power, and then its signal goes out into the gauge. So you power up one and it unpowers the other by using the switch. So that's how the display switching works with that simple switching arrangement there on the side. Quite easy to do. Yeah, as I mentioned earlier, I don't have room for 2 displays. I'm barely going to use the Hall effect sensor on the motor anyway once it's all set up. But this simple switch gives me the capacity to run 2 Hall effect sensors on one display. Works like a charm. I've already had it up and running, but I'll give you another demo once we get all this back together and get it in. Now, all this stuff on the bottom that I haven't gone over, that's inconsequential at the moment. That's for something that I'm going to be doing a bit later on with the mini lathe for another bit of a project on it. So just ignore that stuff, pretend it's not even there. So I think that's just about everything. These are the wires here that go out to the two Hall effect sensors, as I've mentioned. These are just snipped off at the moment. I'm going to run them through the mini lathe, and then I'm using some what are they? I'm going to use a couple of these mini 3-pin Molex connectors. I'll use those to connect into the box out the back, just because they'll fit through this hole in the mini lathe, which is where all the cabling is going to be running through. This is the power to the motor, and I've also just put a couple of insulated spade connectors at this point, so that I can disconnect this unit. Because of the way the back mounts on it, it's quite hard to sort of get this thing apart without taking it off, and it would be easy to be able to take it off, unplug it, take it over to the bench and work on it without having to fuss around with it still connected up to the mini lathe. So just trying to think ahead a bit and make it easy to work with, you know. So all this will go back together. I'll throw a few more cable ties on this and neaten the rest of it up. I just left this loose so I could push it out of the way to give you guys a bit of a look at it before I cable tied it all in. You can see I've done this section down the bottom. It's pretty neat. So I'll do that section, and I'll screw the back on, pull these wires out, and then I'll give you a look at exactly what I'm talking about with that. Okay, so sorry, I'll just go back over this connection into the tack display. So there's a couple of wires that you don't need to use here. I'm not using, where are we? I'm not using 3 and 4, okay? Now, it probably escapes me as to why I'm not, but I know that from memory, 2 and 3 are connected internally, so you only need to use either 2 or 3, and that's where your signal ground and your power ground are both connected. They have them separate on there, but they are connected internally, so you only need to use either one, which is what this cluster here is. Yeah, can't think off the top of my head what number 4 is for, but you don't need to connect it either. So you only need to make 3 connections of the 5 wires that go on this bit on the back of this tacho. So one is your positive side in, your positive power in. 2 is your signal ground and power ground, and 5 is your signal input, which is the black wire from the Hall effect sensors. Okie dokie. So I'll tidy this up and button it up, give you a bit of a look how it looks with the back on it, and we'll whiz around and get it mounted up, and hopefully it should be looking good. Alright, so this is our box fully assembled now, looking pretty sharp. See the back's on, and the way I've got these cables running out is so that we're using gravity in our favour. So the cables are coming, the entry to the cables is in a vertical position. So if any moisture does get behind the control box, it will run down the cables and drip off, rather than running up the cables or running down the cables and dripping into the box, which is something that we don't want. We're doing everything in our favour to keep any potential moisture or anything out of the box. So you can see this hole here on the lathe bed of the mini lathe. This is where the original cables pass through with the original controller that went into the small motor that was mounted in behind there. We're going to use that hole to pass all of our cables through. The reason I used the mini Molex connectors that I'm going to be putting on the Hall effect sensor connectors here is because they actually fit quite easily through this point, and the power to the actual motor will have screw-on connectors, so I'll be able to just release those and bring it back through. Because ideally we want the box to be like this. We want the box to be portable, so that if we do need to do any work on the controller box, all we have to do is disconnect it on the back of the lathe and take it off, pull it apart on the bench, rather than being stuck trying to work on it still attached to the lathe. So I will run these cables through, and then we'll move to the back of the lathe. That'll be fun. Just a thing of curiosity, you can see here there's some aluminium foil mounted under this corner of the headstock. I've just been fiddling around a bit with headstock alignment. The headstock alignment on this machine needs quite a bit to be desired. I struggled with it whilst making up the drive spindle for the new motor. It's where I'll probably be heading next after this, because the alignment is just really up the shit at the moment. Needs quite a bit of alignment work, plus the saddle needs a bit of alignment work in itself, so that's a whole nother thing. But if you have spotted this, that's what it's for, just to pick this corner up a little bit, just to try and get the taper out of the pieces I was making, just to get this done. So I'll mount this box on and give you another look. So here's our new control box, fully mounted now. She's nice and firm. I've just used a couple of 5mm 316 stainless button head screws along the top and along the bottom. Get rid of the crappy screws that originally came with the machine. It looks pretty good. You can see the box is fully sealed up, other than the penetrations, the vertical slots where the power and the output wires for the Hall effect sensors are. If you remember, we've got those breathing holes in the bottom that have the mesh over it. So it's pretty good. I don't think there's going to be any possibility of any bits of swarf getting in there. The mesh will keep, you know, any unwanted intruders like roaches or anything out of the motor controller. It should be pretty good. So I think we'll turn the mini lathe around and we'll have a look at the back side of this and what we're going to do to connect everything up. So here we are at the back end of her. The business end, you might say. We'll just drop this belt off so we can get a bit of a better look at it. Alrighty. So you can see here there's a Hall effect sensor that's been drilled into this plastic cover here. I'll take this off shortly and just show you how it interacts with the magnet that runs the trigger in it. So that's one, that's the short wire that we're going to be connecting up to the motor controller. And our other Hall effect sensor is mounted down here, which is this guy. So all I've done is make a small angle bracket that runs off the motor mount bracket that we made earlier. And as you can see, the Hall effect sensor is just mounted into that. And the magnet, here it comes, is there. Now the magnet does attach itself onto the flywheel, being that it is made of metal, but I have put a little bit of the JB behind it just to secure it there, because I found that the magnet was actually flinging off. So you can see there's just a little bit of clearance there between the two when it flicks past. That's what gives you your signal. Same setup on the top guy. I'll pull the pulley and this plate off, and I'll show you how the magnet sits on there and everything. But for the time being, I'll just throw the camera back in the mount. So these are our cables that are coming out of the back of the machine, and these are our cables here, the two Hall effect sensors, and these are the power wires to the motor. So we've got, you know, the same deal on both sides. We've just got to connect them up. So my plan, I'm just going to mount a plastic box here, drill up from underneath, keep them separated. Ideally I wanted to put two separate boxes up here so I can keep the Hall effect cables separate from the power wires, just because it's not a good idea to have power and signal wires running right next to each other, even though they're well insulated, just so that there's no issues with the power interfering with the signal. I don't think there will be, but yeah, I was going to use two boxes, but I don't really have enough room, so I'm just going to make sure that the entries for both sets of cables are on either sides, and I keep them quite separate inside the box when it's wired up. Not ideal, but you know, you can only do what you can do. This is our box. Got a bit of a seal in it so it's waterproof. 4 screws, and we will mount that on somewhere there. But yeah, you get the idea. We'll bring the wires up through the bottom, and then we can just disconnect from in this position to then feed the cables back through to be able to remove the control box when needed. We could just wire the connectors together, but That's a pain in the ass. If you've got to take stuff apart, you want to be able to separate it without, you know, cutting stuff and then having to resolder it. So it's always a good idea where you've got to get through something like a bulkhead or in and out of boxes to use connectors to enable you to do that where need be. So I'll drill this and I'll tap the headstock, I think, at some point, and we'll get this box mounted. Okay, progress. Here we are, back at the back. The junction box here that I'm using as a place to make all my connections. I've drilled and tapped 2 holes in the back of the headstock here. They're M4, and now the box is securely held in position. This is the one that comes through from the control box on the front, and these are the wires that run into the treadmill motor. And I also have another earth wire here which I'm going to connect onto this existing threaded hole in the back. You can see I've cleaned it up to bare metal around that. I've got a star washer which I'll put underneath it when I mount it on there, just to give me a really good earth connection. These are the 2 Hall effect sensor connections. I've just used a couple of mini Molex connections that I just had in the drawer, and I've wired them in such a way that you can't confuse the connectors where they come through from the control box. One is a male and one is a female, so when you connect them up to the Hall effect sensor, you can't accidentally connect it to the wrong one. So it's a pretty foolproof kind of a method. I've also put an insulated stainless P-clip on the side here just to move this wire out of the way, because it's a little bit in the way when you reach over behind the machine to get to engage the gear selector here. This is our Hall effect sensor here, which gives the speed reading for the spindle. You can see it's just been drilled through the plastic there and just sits there. Oh, where are we? Yep, it just sits there on the inside. The magnet that allows it to operate, you can see it in this position here. That's actually just sitting on there using its own magnetic force to hold it in position. I haven't had to put any JB on that. It seems to sit there fine by itself. Obviously it doesn't spin as fast as the one on the motor does. So for the time being, I'm just going to leave that, as it hasn't flung off yet, and I can't really imagine it's going to fling off. You can see here I've already replaced the plastic spacer that was in the headstock that you would have seen when I did the bearings in it. It's now been replaced with a piece of aluminium that's the correct thickness, as the other one was not even the correct thickness. And I've also used that I've also done a bit of work to line the gear train up. You can see all the gears are properly aligned and meshed perfectly. There's a few washers here and there in behind all this setup here just to get that perfect alignment, and it's really good now. So let's pack everything in this box and see how we go. Let's go, guys. What I got here? Generally, when I do any connectors like this, I'll usually throw a bit of heat shrink on before I put the pins in, so that where you've got your stripped off insulation on the end, where you lead into the bare wires, you can just slip the heat shrink back when you finish making the connection. Just keeps it nice and tidy, adds a little bit of protection to the bare wires there, and does a pretty neat job. You can see it's on both sides there on all the connectors. Just another one of those things I like to do. So let's see how this is all going to fit. That's looking pretty good. You can see I've just done these as a slot in the bottom here, just so that nothing needs to be connected or disconnected to actually get it out of the box. Just for simplicity. So you can see all that's going to pack in there, no worries at all. Yep, very nice. I already fitted the seal into the box. So the box is completely sealed other than the bottom, which so if any liquid or anything gets on there, it's just going to drop off. It can't really shoot up in underneath. So it should be quite good. It should be just quite a really good place to make these particular connections. This bloody box together. Oh yeah, it's not going to happen like that. Well, holy dooly, that took a long time. That's a bit better. Beautiful. When I chose this P-clip that I've used on the back here, I chose a clip that had a little bit of slack in it so that I can slide this up and down for when I remove this cover. I didn't want something that would be fixed in position too firmly that would stop me actually pulling cable through and allow me to remove that. As you can see, look, that's about as neat as I can get it. I'll cable tie these wires in away from that handle there, but it's not too bad. I'm aware that this cable's here, so it's just going to sit like that. But it'll be right. I might throw those screws in and put that back together. All I've got to do now is find the bloody screws. Think, Trevor, you stupid old fuck. Where did you put them? Jesus Christ. Ah, I've got them. It's all right. Don't panic, everyone. Here they are. Looking good. All right, I'll just drop this this earth point on over there. Very important having all your earths. Don't forget to get all your earths in. No earth, you die. Okay, so star washer behind it, just so we get a bit of bite into the steel and a bit of bite into the connector. Flat washer over the front to keep it nice and squashed down. And there it is. Beautiful. Nice solid earth. So not only do we have the heatsink and everything earthed out inside the box there, we've got a continual earth that runs through from the power input on the front all the way through. These cables are all earthed on the back, and that extra earth there that goes on the headstock, and thus will earth the entire mini lathe, which I'll demonstrate the earthing when I get a plug hooked into it. I'll hook the multimeter up and I'll show you how everything's earthed out really nicely so it's nice and safe, which you have to do. Oh, that's better. Nice and neat. You've got to keep it nice and neat, ladies and gentlemen. If you're serious about your shit, keeping it neat is the way to go. Why did I undo that? Who knows? I do some pretty strange shit sometimes. Anyway. Throw this sucker back in. Beautiful. The belt back on. bit of tension. So that's the back finish, and as you can see, it's pretty tidy, pretty neat. The box is very secure. The cabling is all very secure. Gee, I think I might just put one more cable tie on that. Jesus Christ, I've shot myself in the foot. Secure, is it, Trevor? God damn it. Okay. So. So as you can see, we're pretty much finished at the back here now. All the cabling is nice and tidy, everything is secure. The cables are held nice and firmly, they won't abrade on anything from flailing around and vibrating. All in all, looks pretty professional if you ask me. So, we're finished on the back side, so let's flip her over back onto her back. Okie doke, she's back the right way around now, so let's get a power lead in it. And let's just check all these earths just to make sure that everything has gone the way I think it has. So I have my trusty multimeter here. I'll just set it onto the aim setting, which has a beeper on it. Just test him on the end of the plug there. There we go, nice loud beep, display flashing. So, if I've done my job correctly, everything we touch should be earthed. So, let's start checking it. The chuck is earthed. Tool post holder is earthed. Lathe bed is earthed. The handle is earthed. Everything is earthed. Even the pulley. So, as I've demonstrated there, we have successfully earthed the entire machine. So if there is a short anywhere, the easiest way to go to ground is through that earth wire and not through my body. So far so good. Let's plug her into the mains and see if I've wired it up properly. This is going to be embarrassing if it doesn't work. Just let me say that right up front here, because there is a lot of wiring I've done. Alright, let's give her a crack. Where's the camera? There it is, righto. Okay, here we go. Cross your fingers. Oh, look at that. Tack display, a nice pretty blue. There's our power on light. Speed control, forward and reverse. And a bit of secret sauce down the bottom here. Let's see how we go. Alright, let's put it on to forward and start a running. Oh, look at that. The motor speed controller, as you can see, it's actually down on the motor. So I'll flick it back up onto the spindle. So the motor's doing 769. Up onto the spindle, which is the top there. So we've got about 300 RPM on the top. I won't run the machine too fast because there's nothing in the chuck. I do have the jaws done up, but you know, it's not a good idea to run it with nothing in it. So at this point, we're just testing to make sure it all works. So there you go, we've got 329 on the top. Flick it onto the motor, it changes over, and we've got 849 at the motor. That's a pretty good reduction. Alright, getting back on the top. We'll turn him off. Set the pot down to nothing. See how we go on reverse. There we go, the tacks drop back to 0. They are a little bit slow, these guys. Look at that. We've even got reverse. We've got reverse, ladies and gentlemen. So there you go. 300 RPM in reverse. Put him down on the motor. 825. 826. 320. So everything appears to be working really, really well. So we have success, ladies and gentlemen. The new control box seems to function flawlessly. We now have our variable speed, forward and reverse. We're able to switch the tack between the spindle and the motor to give us our different speeds. Powering on the front here. So that's looking pretty bloody good. At this stage, I think the next thing that I'm going to do is to get the headstock aligned and align the saddle as well. I know that the headstock is actually out of alignment. I've struggled with it while I made a few bits and pieces to enable me to do this conversion, and it was a bitch, believe me. So I'm going to have to spend a bit of time aligning the headstock before we can start making anything, but we're getting pretty bloody close to actually start making some chips for real on the mini lathe. I might even set up to mount it in its final position, get the bottom of it bolted down, get all the trays back on. Bloody beautiful. One quick thing I didn't mention. When the chip tray goes on the back here, it will actually shield the motor. Where the motor is at the back there, it actually seals off that area and stops any chips flying into where the motor is. I'll see how it goes. If it does seem to, if it is getting any swarf down there at all, I'll maybe extend this this chip tray. But for the moment, it's all looking pretty good. I'm quite happy with how that's all turned out. So as always, ladies and gentlemen, thanks for stopping by the Aussie Shed. Always a pleasure to have you here. Remember to like and subscribe, and if you'd like to support the Aussie Shed, there's a PayPal and Patreon link in the description. I'll throw a whole heap of eBay links in for all the bits and pieces that it took to convert this original motor controller into what we have here. There's also, I'll put links at the end of the video to my motor controller video, which will also has links to all the bits and pieces. I'll throw them in here as well, just so you don't have to sort of swap between the two. Hope you found that interesting. I hope it inspires some of you to do a similar kind of thing, because believe me, this will beat the shit out of the original setup, hands down. So once again, mate, thanks for stopping by the Aussie Shed, and I'll see you on the next one. Cheers.